Hello viewers, so we have this question that says an element consists of 1.40% of an isotope with a mass of 203.973 atomic mass units, 24.10% of an isotope with mass 205.9745 atomic mass units, and another one with 22.10% of an isotope with mass of 206.9759 atomic mass units. And another one is 52.40% of an isotope with mass 207.9766 atomic mass units. Calculate the average atomic mass and identify the element. So our job is to calculate the average atomic mass and then later on identify the element. So how do we find that? Now, when you look at the periodic table, the atomic mass mass units or the masses of elements there are basically not whole numbers. The reason why is those elements exist as isotopes. So the mass that is written on the periodic table is an average of the masses of these isotopes. That's why we have those to be not whole numbers. Now, how do we find these average masses on the periodic table? Now, given this information, in order for us to find the average atomic mass of this element using the isotope information, the formula we need is the average atomic mass. So average atomic mass is equal to the sum. Now the sum of the percentage abundance like that. So this is the formula we need. Divided by 100% multiplied by the mass of that isotope. Yes, so this is the formula we need. Now, we need to understand what this formula really means. What does it mean? Now, what it means is when we say the sum, this symbol here represents the sum. So when we say the sum of this that we have here, abundance, percentage abundance, divided by 100 multiplied by mass of isotope, we mean we are going to say, for example, in this element here, we've got 4 isotopes. We have one that has got a percentage abundance of 1.40%, and then it has got a mass of 203.973 here. Yes. And then we have another one that has got a 24.10%, and its mass is 205.9745. And we have another one that has 22.10%, and it has got a mass of 206.9759. And we have the last one that has got a percentage of 52.40, and it has got a mass of 207.9766. Now, what we mean here is the sum, meaning the percentage abundance of this one divided by 100%, then multiplied by its mass, which is there. We find a value there. Then we are adding it. Sum means addition when you add all values. So the sum, we mean after finding this expression here for one isotope, we also use it for another one. We use it for another one. Then the values we are going to find is what we add, and then that will be our average atomic mass. So that's what we need to do. In short, what we are saying is this will be equal to, in this case, we'll say this is equal to, we have 1.40%, and this will be divided by 100%, and then multiplied by its mass is 203, so 203.973, like that. This whole thing here will be added to the next one, which is we have 0.10%. This is divided also by 100%, like that, and it will multiply by its mass, which is 205.9745, like that. So this is added, and this will be added again to another one, which we have here to be, the percentage is 22.10%, and this will be divided by 100%, and this will multiply by its mass again. Its mass is given as 206, so we have 206. Let me write that down to create space. So, let me write it in small fonts. So yeah, what we are going to have here is we have, this is 22.10% divided by 100%, and this will multiply by its mass, which is 206.9759, like that. So that's what we have there. And that will also be added down here. We'll say it will be added to, we have the last one, which is 52.40%. And this must be divided by 100%. Then we multiply by its mass, which is 207.9766. So this is what we mean when we say the sum of the percentage abundance divided by 100 multiplied by the mass of isotope. This information that we have collected here is what we mean. You can see this is the information for the first isotope. This is the information for the first isotope. We have this for the second isotope, for the third isotope, and we have for the fourth isotope. So we are adding what we are getting here to what we are getting there, to what we are getting there, and to what we are getting here, as you can see. So let's do mathematics. Let's do our mathematics there. Now, when we do our mathematics, what I'm finding here is for the first isotope, I'm finding a value rounded to 2 decimal places to be 2.86. So I have 2.86, and this will be added to, for the second one, I'm finding 49.64. So 49.64 for the second one, and then the third one, I'm finding 45.74. So 0.74, and then for the last one, I'm finding 108.97, no, 0.98 when we round it off to 2 decimal places. So 0.98, like that. So this is what I'm finding. Now, we need to add those values, and what we are going to find is basically the average atomic mass for this element. So let's quickly do that. When I add 2.86 to 49.64 to 45.74, and then add it to 108.98, what my calculator is giving me is 207.22. And this is in the atomic mass units. Yes, so this is our average atomic mass, 207.22 atomic mass units. Yeah, so that's the value we are finding, and this is how we basically find the average atomic mass for an isotope. So the process is we follow what we have here. As you can see, the formula is this one. Average atomic mass will be equal to the sum of what we have here, percentage abundance divided by 100 multiplied by mass of isotope, like that. So that's what we use. And then we just replace. You pick information for each isotope accurately. For this one, for example, we had this percentage and its mass is there for this isotope. So we pick it the way it is and then just do mathematics and we'll be able to find our average atomic mass. All right. So after finding our average atomic mass, all we have to do is, yes, we found it here, 207.22. That's our average atomic mass. In order for us to identify it, we just need to go on our periodic table and look for an element that has got a mass number that is 207.22, or the molar mass, in other words. So when you go to your periodic table, you find that, for example, let's get an example of let's get sodium. Yes. So you find that sodium is an element. It has got a value of 11 and a value of 23 here. If you are using a whole number rounded off to the nearest whole number periodic table, where the mass numbers are shown as whole numbers. But still, yeah, the point here is an element will have two values that is connected to it. So you have the smaller value and you have the bigger value. Now, the smaller value is the atomic number. It represents the number of protons in that nucleus. And then the bigger value is what we call the mass number, okay, or the molar mass. Now, this one here represents the number of protons added to the number of neutrons in the nucleus of this atom. So this is the number we are looking for, the bigger number, not the smaller number that represents the atomic number. No, not the atomic number, but the mass number that we have here. So you go on your periodic table, you look for an element that has got this mass number here, 207.22, and then you basically identify it, meaning that's what we are looking for. So 207.22, or rather it can be 207.2. If you're using a rounded off to the nearest whole number periodic table, you find it as 207. So yeah, as long as it's 207.2 is 207, it means that's the element we are looking for. So according to my periodic table here, which is also supposed to be according to your periodic table because we basically use the same periodic table, the element that has got a mass number of 207 is lead. So this element here with an element symbol of Pb is an element known as lead, and this is the element that has got that mass number, meaning we've basically identified the element like that. So that's it for this video. Thank you.